Hello children, so these are the numericals based upon BIOT SAVART'S law and magnetic field due to a straight wire. So let us discuss. First numerical. A wire placed along north-south direction carries a current of 8 ampere. So note down the particulars. Current is 8 ampere. Find the magnetic field. Find the magnetic field due to 1 centimeter piece of wire. So that is length of current element is 1 centimeter changed into meters at a distance of 200 centimeters. So that is your distance in northeast. The point where you need to find out the magnetic field is in northeast. So this is the diagram. This is your wire which is kept along north-south. Okay, and this is how current is flowing. They wanted to say that the current is flowing like this, south to north. It is here. Okay, so this is a point along northeast where we need to find out the magnetic field and distance is given. So all the particulars are given. I, length of the current element, and distance and angle. Northeast means angle is 45 degree. So we'll make use of BIOT SAVART'S law to find out this magnetic field. dB is equal to mu naught by 4 pi I dl sin theta by r square. All the quantities are given. Mu naught by 4 pi, everyone knows that is 10 to the power minus 7. You can substitute the values and you can report the answer in Tesla. Okay, now because magnetic field is a scalar quantity, so we need to tell direction as well. So we'll be making use of right hand thumb rule. So you can see current is like this. Current is given like this. So this is your thumb, which is along current, and point is here. Point is on right. Okay, so point is here, wherever, here or here or here. So you can see that the fingers are going inwards. So it is normally inwards into the plane of paper. So two things you have to report: the magnitude of magnetic field and the direction. Getting to next, an element del L vector is equal to del x I cap. That means current is flowing along positive direction of x-axis. So this is my current. Okay, and current is how much? It is 10 ampere. You can see here it is written 10 ampere. Okay, coming to next, what is the magnetic field on y-axis? Current is flowing along positive direction of x-axis, but you have to find out the magnetic field on y-axis. That means theta is 90 degree. And distance is given as this. The only thing which I didn't find is length of the current element, which is given at last. So this is length of the current element. Current is flowing along positive direction of x-axis. So all the quantities are there. Mu naught by 4 pi, you know. Current is given. Where is current? 10 ampere. The length of the current element is 1 centimeter. Sin theta is sin 91 and distance of the point is given here is 0.5 meter. You can substitute and find out the magnitude of magnetic field, but then magnetic field is a vector quantity, so you need to tell direction as well. So you can see this situation fits it. This is the direction of current and the point is somewhere here. So these fingers are pointing out of plane of paper, so it is normally outwards. So getting to next numerical. So here it is given length of the current element is 2K and current is that. That means current is flowing along positive direction of z-axis. So this is my positive direction of z-axis. So this is current, right? We have to find out the magnetic field on x-axis. That means theta is 90 and distance is given. And length of the current element is this. If you look at it, this is length of the current element 2 mm. You can convert into SI unit. So my length of the current element would be 2 into 10 to the power minus 3 meters. And distance is here. So again mu naught by 4 pi, which is 10 to the power minus 7. Current is there as 2 ampere. So this will be substituted here. And length of the current element we have just written. Sin theta is 90 because you have to point is on x-axis. Current is along z-axis. So theta is 90. And distance is given as 3 meters. You can substitute and you can find out for each numerical. Distance is given as 6 meter. You can substitute. Distance given as 3 meter. You can substitute. But look here. This point is located on z-axis and current is also flowing along z-axis. So angle between them will be 0. So sin 0 will be 0. So here answer is 0. Okay. So magnetic field you can find out like this. Now coming to the direction part of the question. for direction here, because things are given in I cap, J cap and K cap, so you can use your BIOT SAVART law in vector form. It means this quantity can give you the direction dl cross r. dl, that is current element, is along K cap, that is positive direction of z axis. Okay, for first part your point is on x axis, that means it is I cap. Now what is K cross I? It's this J. So for first answer, number can be found, magnitude can be found by this formula, right? And J, that is direction, has been told by this thing. So this is how we can report. Otherwise you can solve in the cross product as well. Okay, now coming to the next part, it is along negative x-axis. The point is along negative x-axis. So direction will be found by K cap cross minus J. Right. Now minus outside, K cross J is, so you can find out K cross J. Okay, so that will be your minus side, so you can substitute. Sorry, not K cross, sorry, the point is along x-axis, so that means it is located at x-axis. X-axis means I, so we will write here I. Okay, now K cross I, you have to see, K cross I will be J, so K cross I is J, so minus is here, so it is minus J, and you can see here it is minus and then J. So this is how you can do these numericals. Getting to next, an element this is placed at the origin as shown and carries a current of 2 amperes. So current is there, this is distance, length of the current element, so all the things are there. We have to find out the magnetic field. So this question is for your practice, and please check your number as in magnitude and direction both. This is for practice. Okay, getting to this question, a current of 10 ampere, so note down the particulars, current is given as 10 ampere, is flowing from east to west. So this is my east, this is my west, and this is my direction of flow of current. Find out the magnetic field at a distance of 10 centimeter north. So this question cannot be done by using BIOT formula, and because length of the current elements is nowhere mentioned. You can see here we have current's direction we have, and we have to find out magnetic field. Okay, and distance is given. So which formula will be used? We will use the first application of BIOT SAVART'S law, that is the magnetic field due to a straight wire carrying current. Okay, how? Because we have this formula, magnetic field is equal to mu naught by 4 pi, which is 10 to the power minus 7. Current, yes, current is given. Perpendicular distance, yes, this is a perpendicular distance, and because it is a long wire, or you can consider let it be a long wire, sin phi 1 and phi 2 will be sin 90 and sin 90, and sin 90 is 1. So 1 plus 1 will be 2. So we will do this question by this formula, not by the formula of BIOT SAVART'S law. Okay, because length of the current element is missing here. So current is given, perpendicular distance is given. You can find out the magnetic field. Again, finding out magnetic field will not make your question complete. You have to tell the direction as well. So you can see the current is flowing from east to west. Here it is written. So we'll have to find out the magnetic field, and the point is in north. Okay, so we'll use right hand thumb rule. This is your current. This thumb is your current. And magnetic field is to be found here, so it is normally inwards. So it is normally inwards for first part. In second part, it is 20 centimeters south. So, see, numerical you can solve on your own because distance is only different, perpendicular distance is different. So you can put a different value of perpendicular distance in the same formula. Magnitude you can obtain, and for direction you can see this is current and point is located here, that is here. So it is normally outward for second part. Now let us see two more parts are given. 40 centimeter downward. The point is 40 centimeter downward. Okay. So, and 50 centimeter upward. So you can see you can see in this picture, this is my current and my point is here upward. The picture is not in 3D, it's in 2D. Otherwise, I have performed in 3D. So, you can also hold your thumb like this. And the point is not here on the screen, but up. Okay, so you make your curls reach there, up. Then you will find that the magnetic field is, see, you will be arranging it like this. Your curls will be going like this. So, you will see that your fingers are pointing away from you. Fingers will be pointing away from you. So, that is the direction of magnetic field. Away from you, or you can say away from you is north. So, you can write it. It is from south to north or simply along north. Now, 40 centimeter downward. So, current is like this. Your point is downward. Downward means below the mobile. So, make your fingers reach there. Reach there. When you will make your fingers reach there, you will see that the fingers are pointing towards you. So, that is, these fingers are pointing towards you. You have to imagine. So, it is towards you. And what is towards you? Towards you is south. So, you can write this, north to south. Or you can write towards us, towards the observer. Like that. So, please understand that current is flowing from east to west. Okay, it is above the mobile screen. So make your fingers reach there. You will see the fingers are pointing away from you for second part. And what is away from you like this? North. South to north is direction. So let us see the next question. Example number 4. So a long straight wire. Long means phi 1 and phi 2 both are 90. Current is 30 ampere. Okay. There is a long straight wire which is carrying a current of 30 ampere. It is placed in external uniform magnetic field. So there is a field already. There is some external field in this question. Okay. So, and it is parallel to the current. There is a wire which is kept in external field. So we have to find out the magnitude of resultant magnetic field at a point 2 centimeter away from the wire. So let us look at the situation first. This is the wire. This AB or AC is the wire. Okay, and we have to find out the magnetic field at this dot. This. We have to find out magnetic field here. Now, here one magnetic field will be exerted by this current carrying wire, and one magnetic field is already there whose direction is parallel to the current as per the question. So, one magnetic field is already there. And one magnetic field will be that of wire. You can see current is like this. So, magnetic field will be inwards. So, let us say this is that inwards. I can show on screen like this only. So, this is my B inwards. Okay, due to the wire. So, one field is this way, one field is this way. We will use parallelogram's law to find out, parallelogram's law of vector addition to find out the magnetic field. This is magnetic field. External square magnetic field due to straight wire square plus 2 into A into B into cos of theta, which is 90 between them, right? Both the fields are at 90 degree, cos 90 is 0. Okay, so our question is to put the values of these. Now, out of these two, external field is already given. External field is given as this. So, you can substitute. Our only job is to find out the magnetic field due to this wire at a distance of 2 centimeters. So, as you can see, mu naught by 4 pi, I by perpendicular distance 2 centimeter, you can convert into meters. Sin 90 plus sin 90, current is given, substitute, find out the value. You can see I have found and I have written the direction. Whenever you are finding the magnitude of magnetic field, you will have to find out direction as well. Substitute. So basically in this question we were supposed to find out, let me show you once again, we were supposed to find out magnetic field at this point, but at that point this wire is also exerting an inward magnetic field which is denoted by this is B straight wire, and one field was already acting parallel to the direction of current which was B external. Now because they are acting at some angle 90 degrees, so we used parallelogram's law to Find out net magnetic field. And now we have done parallelogram's law in class 11th, that if two vectors are acting at some angle, we'll close the parallelogram. Net magnetic will be along the diagonal, and the direction is given by the formula of tangent beta. If you remember, what used to be the formula of tangent beta? B sine theta divided by A plus B cos theta. So anyone can be B, like B external is B, so B, and it is BA. All the numbers you have, this is 90 and this is 90, to substitute and find out tangent beta. Okay, so coming to the next question. The figure shows two current carrying wires 1 and 2. Find out the magnitudes and directions of magnetic field at P, Q and R. So at P, we have to find out, this is 1. At Q, Q is here. So let us do for Q. See, I have done it at point Q. So if these are both straight wires, wire number 1 and wire number 2, both are straight wires, so we'll use the formula. Formula is clear. Unit by 4 pi, I by perpendicular distance, and sine y1 plus sine phi2. Let it be long. If angles are not given, let this be long. So substitute sine 90 plus sine 90 is 1 plus 1 is 2. Current is given. I am finding for first wire. So this is my first wire. What is my current for it? Here it is written 20 amperes. So I have written here 20, right? What is the distance of point Q from first wire? 10 centimeters. 100 will go up. Solve it down. You will get this number. What about the direction? So see, this is the direction of current. Yes, here it is written. This is direction of current. Okay, and we have to find out magnetic field at this point Q. This is the point Q. So this situation is suiting it. It is inwards. So I have written here normally inwards. Now coming to the magnetic field due to other section of wire, other wire. So B2, second magnetic field. Same formula, mu naught by 4 pi, current will be 30 this time and distance is 10. Again, you can substitute, and I have found it like this. Then I have to tell direction. So you can see this time current is down, towards you. Even if it is not down, then it is towards you, right? This is current. So this situation is suiting it. Again, magnetic field is inwards at this point, right? So this is normally inwards, normally inwards, normally inwards. They both will add. So this is net magnetic field. Again, you have to tell direction. So this is net magnetic field at point Q. Now coming to point P. So let us take point P. This is my point P. This is my first wire. This is the current. So point is here. So it is normally outwards. So you can write it normally outwards. This is my second wire. So this is my current. This situation is suiting it. Point is here. So point is here. So it is normally inward. So one field is normally outward. These fingers due to B1, and B2 is normally inward. So both will be subtracted. In subtraction, whoever is large will be kept first, and net field will be in the direction of larger one. So let us find out magnetic field due to first wire. Same formula, mu naught by 4 pi, I by perpendicular distance. I is this, perpendicular distance is 10. Sine 90 plus sine 90. Calculate, put direction. Coming to next, same formula. Only distance of point P, this point P from second wire would be 10, 20 and 30 centimeter. Find it out. I have found. So they both are opposite. One is outward, one is inward. So this is bigger. So it will be kept first. B1 will be kept first. Subtract. This will come. And B1's direction will be the final answer. So I have found this question for point P. You can see point P and point Q. You will be doing it for point R. Coming to the next question. Use BIOT SAVART'S law to obtain an expression for magnetic field at the center of a coil bent in form of a square of side 2a. So very important question. Let us understand. This is my square. You can see a square here. So this is my square. And length of side is 2a. So you wish, you can locate. Now this is the sense of current. You can see this purple arrow. This is the sense of current flowing through the square. Okay, so you can find out, see, if the sense of current is same, like current is flowing like this, है ना, sense of current is same, so it means magnetic field of all the wires will be added. There are 4 pieces of wires, so you can see this is my current, this wire I'm talking about, A, B, है ना, and my center is here. We have to find out magnetic field at center, so my field is inwards, first field is inwards. Second, current is like this, yes or no? Yes. And magnetic field is to be found here, so it is also inward. So that's how I'm saying that it will be inwards for all, if the sense of current is same. Okay, so yeah, so we have to add all the fields because wires are identical. So it will be 4 times magnetic field due to one piece of wire. So okay, 4 times, let us open it. Every side of wire, every side of square is a straight line, and we know the formula mu naught by 4 pi I by perpendicular distance sin phi 1 plus sin phi 2. But here phi 1 and phi 2 will not be 90 because it is not infinitely long, it is a finite length. Side of a square is a finite length. Okay, so let us see what would be phi 1 and phi 2 and what would be perpendicular distance. So perpendicular distance of center you can see already from the figure. Let us understand it. See, the whole side is 2a. So this will be 2a, this complete line, orange line, and this much, the thick orange would be a. So a, that is half distance, is going to be my perpendicular distance. You can substitute here. Coming to sin phi 1. So this wire AD, end of this wire A, this A is making this angle phi 1. How much is that? So let us see how much is that. This is 90. This is 45. Square का angle bisector है ना, and this will be 45, and remaining will also be 45. So phi 1 and phi 2 for this square will be 45 and 45. Substitute 45. Sin 45 is 1 by root 2. Now we know all the quantities. We know this perpendicular distance we know is A, that is half of side of square. Current is I. They have allowed the symbol. You can see in the question they've said current is I. Right. So you can substitute and you can find out the answer. This is magnetic field and yeah, direction must be written. See, I've written here normally inwards. If somebody is taking the sense of current like this, for him it will be outwards. Okay, coming to the next question. A current of 1 ampere is flowing in the sides of an equilateral triangle. Of side this, find out the magnetic field at the center right of the triangle, right? So this is this triangle, you all can observe SQT, you can say. This is my triangle. Now see, sense of current is same in all. One current is flowing, no? So we can take thrice of magnetic field due to one wire. So it will be again formula is same, mu naught by 4 pi by perpendicular distance sin phi 1 plus sin phi 2. Phi 1 and phi 2 will again not be 90 because it is of the wires are of finite length. So let us see what will be the angle and what will be the perpendicular distance. Anyways, current is given as 1 ampere, so you can substitute current. Now let us find out what is phi 1 and phi 2. So this is an equilateral triangle, right? So this angle is 60. So half angle is 30. This is 90. So 30, 90, 120. So remaining angle, this one is 60. So this is my phi 1 and phi 2 is 60. Sorted. Now the whole side of the triangle is given. Okay. So half side is also known, right? And we have to find out ON, that is perpendicular distance. So see, I've written here ON up, base down, base is SN. I have to find out ON, and this is my 30. So this is perpendicular, this is my base. So we can use the formula of tangent 30. And this is your half of side. Side is given in number 4.5 into 10 to the minus 2. This is side. So SN will go that side. Side by 2. Half of side is SN. Tangent 30 is 1 by root 3. ON is calculated. That is perpendicular distance. You will substitute here. Do simple mathematics. And find out the answer. But then again, direction must be written. So because you have taken, I have taken the sense of current like this. Like this I have taken. So for me, this will be thumb and my fingers would reach like this. You can see from here picture. And my current is like this. So fingers are inwards. So normally inwards. If somebody is taking otherwise, so for him it will be normally outwards. Next question. To infinitely long. So it's good infinitely long. That means sin 90 plus sin 90 is 2. So I've written here directly. This is my mu naught by 4 pi. This is my first current. This current I1. Check it out. Yes. What is the perpendicular distance of point P from I1? 4 centimeter. Substitute, calculate, then wait. You will have to put direction as well. So let us talk about the direction. So you can see current is this. So this situation is fitting. Point is here. यानी कि right side में point है. So this is normally inwards. Coming to next. Now my current is like this. So this is my current. Point is here only. So it is also normally inwards. And a formula you use. So both can be added. And again it will be normally inwards. So getting to the next question, we have to find out magnetic induction. So yes, magnetic induction is also another name of B, magnetic field. At the center of a coil bent in form of a square of side 10 centimeter. So in form of a square we have just done, you can take it, let it be a hexagon. So we have taken an hexagon. Okay, in place of a square question we have done just now. So let the current be like this or whichever. So now because sense of current is same, the magnetic field of all sides will be added. It will be 6 into side magnetic field due to 1. Okay. So mu naught by 4 pi I by perpendicular distance I is given as this. Perpendicular distance we don't know and phi 1 and phi 2 we don't know. Again we have to use some mathematics. The whole angle, each angle of hexagon is 120. So this is 60. This is 90. 60, 90, 150. So this is 30. Phi 1 is 30 and phi 2 is also 30. You can substitute. Right? Okay. Now coming to the perpendicular distance. Perpendicular distance is this. ON. We don't know. So up, down, the base of the triangle. This is side by 2. Side is given. Side is given as 10 centimeter. Okay. So now it will be your perpendicular by base. So it will be tangent of 90, 60. So yeah, this is 60. Half of each angle of regular hexagon is 60. So it will be equal to tangent 60. Find it out. This is your perpendicular distance. Again, please understand the question of square is very important, but we have done one. So I change it into hexagon. Getting to the next question. To infinitely long, so phi 1 and phi 2 is 90. Infinitely long or simply long, or if no mention of angle, then usually we will take phi 1 and phi 2 90. But if it is a finite length like a wire of square or hexagon or any other shape, so we'll be finding out phi 1 and phi 2. So they carry current I1 and I2. So we have to find the magnetic field at point AB. So here it is AB. See, this labeling will not be given to you. You will have to label it on your own. Okay? So actually, see, yeah, B is a point on y coordinate, na? So this will be V. This you have to label. Just because we are seeing the diagram, so we feel that it's easy. No. This is x coordinate, so A is here. So this is A. Okay. Such question comes in exam with points like 7 and 13. Then you have to label the distance on your own. So keep in mind that first magnetic field will be mu naught by 4 pi. Find I1 is I1. Perpendicular distance would be x coordinate. Okay. And sin 90 plus sin 90. What about the direction? Current is like this. So this is current. Magnetic field here would be inwards. So right here normally inwards. And similarly, for second wire current is like this. And point is here and is outward. So you'll have to subtract. You'll have to subtract. Again in subtraction, which will be kept first? This is B1, right? Coming to B2. B2 I have not written, but it will be same only mu naught by 2 pi. Only I2 will come and B will come. And it is normally outwards. So this is your B2. So both are opposite in direction. So they will be subtracted. Now who will be kept first? which is more. Who's more here? We don't know. So, though there is no comparison, but still you can assume that its distance is less, B is less from the diagram. So, its magnetic field will be more, we can assume so. So, B2 is greater than B1, so you can substitute. So, because B2 is greater, so its direction will be written as net magnetic field's direction. Coming to next question. This is important and different. There are two wires AOB and COD. They are carrying current I1 and I2 respectively. We have to find out the magnetic field at a point P in a direction perpendicular to this plane. So please understand that this is first wire. So its magnetic field here would be C. This point is not in this plane. So this is not on my mobile screen, on my laptop screen. This is in air, like above. Okay? Above the laptop screen or desktop screen. So you can keep your thumb along this. Okay. And above, this is above. This is not on screen, it is above. So your fingers will point away from you. So let this be this magnetic field. Fingers away. This is away. This is first magnetic field. Away from you. Okay, second wire is like this. So this is carrying current like this. So your field at this point will be outward. So okay, let this be outward. This is outward. This is normally outwards. Kindly please listen. This was your current, and this point is not in the laptop screen. It is like above. So this picture will suit it. This is current. And this is above. So fingers will point, if you will make your fingers reach there of right hand, fingers will point away from you. So this is my magnetic field. This is my B away. This is my B first. And what about second one? This is the current, right? And so it is outward. So I'm saying let it be outward. What I wish to see that both are not acting in the same direction, both fields are not acting in opposite directions, they cannot be added or subtracted. We'll have to use parallelogram's law. Okay, so B1 square, B2 square plus 2B1, B2 cos of 90. One field is like this, one field is like this. So it's 90 cos 90 is 0. Substitute both the values, mu naught by 4 pi. Current by perpendicular distance, sin 90 plus sin 90, so that will be 2. 2 will cancel out 4, so it is 2. Substitute, take common. Matlab use mathematics. Mu naught by 2 pi a, mu naught by 2 pi a is common. Square is common. When square will come out, it will be single power. So this is the answer. And what about the direction? Because here we have used parallelogram's law, so direction will be told by this formula. B sin theta by A plus B cos theta. Anyone can be B. And next is A. So this is how it needs to be reported. It is an important question because here the point is not lying in same plane. The point is not on mobile screen. Point is in air. Okay? Okay. Thank you.